Here's the crazy part. The story of 3I Atlas didn't begin when telescopes spotted it. It began 48 years earlier when a narrowband whisper near the hydrogen line lit up an old radio dish and then disappeared. Everyone moved on. The data sat in archives dusty and misfiled. Now with better tools and smarter pattern hunting, engineers lined it up with 3I Atlas's path and finally cracked the structure that was hiding in plain sight. If this holds, the signal wasn't random. It was a clock. And the clock was set for now. The old burst that wouldn't fit the box. Most people have heard of that famous 1977 radio blip, the one that hit right near 1420 MHz and then never repeated. It was short, strong, and maddeningly tidy. Back then, the rule was simple. No repeat, no case. Teams checked for interference, satellites, meteor scatter, you name it. With nothing obvious to blame, the event was filed under interesting, unsolved, and radio astronomy carried on. Decades later, something new messed with the neat filing cabinet. An interstellar object, 3 Atlas, blew past early models and behaved like the universe's headstrong middle child. Its light curves pulsed in regular spans. Its non-gravitational nudges showed up in the exact windows you'd expect if a low-thrust system was spooling up and idling. At first, the connection to the old radio burst sounded like a stretch until someone overlaid the timing of Atlas's activation phases on top of the archival radio envelope. The cadence wasn't identical, but the ratios lined up suspiciously well. That's what cracked the door. If the 1977 event was not a one-off call at the start of a long countdown, the no-repeat rule stopped being helpful and started being a blind spot. The original burst didn't need to repeat. It only needed to index a schedule that wouldn't mature for decades when the transmitter and receiver Atlas and US would swing into a geometry that finally made the rest of the pattern visible. This is the part that hooks people. The signal may not have been a message in the human sense. It looked more like a timestamp, a seed for a later decode. How a non-sage becomes a decoder ring. So what does decoding really mean in this context? Not a secret sentence hidden inside static. Think simpler and smarter. The 1977 burst can be treated as a primer, a short reference with known physics that lets you reconstruct a key. Hydrogen line proximity gives a universal yardstick. The measured blue shift provides a relative velocity. The dynamic range of the amplitude sets a scaling window. Combine those three and you get a template you can slide across future datasets. That's what the new analysis did. Engineers pulled long baseline logs from radio, infrared, and optical archives all the way up to the present. They then stretched or compressed each dataset according to that primer template. Suddenly, previously random brightening and quieting around 3I Atlas snapped into phase. The important part wasn't the raw values. It was the spacing, bursts, fades, nickel line upticks, and even albedo dips lined up in consistent intervals once you applied the primer. Imagine a player piano roll with hole. You can't see until you shine light at a certain angle. The 1977 burst supplied that angle. When you looked with the right timing, structure appeared. Groups of intervals that repeated in modular packets. 5-8-13 ticks separated by longer resets. Those counts echo familiar growth ratio. But the key takeaway is not poetry. It's engineering. Modular packets are how you build robust timing in noisy environments. You don't try to shout an essay across a stadium. You clap a beat everyone can pick up later, especially if they saved the first clap. Decoded this way, the old burst becomes a phase aligner. It tells your analysis where to plant the ruler. Once planted, Atlas's behavior looks less like a chaotic comet and more like a system running through cycles. Charge, test, correct, quiet. Not proof of intelligence, but definitely proof of discipline. The geometry trick that hid the pattern for decades. If this pattern was sitting there all along, why didn't anyone catch it earlier? Geometry. The 1977 burst came from a sky sector that later became relevant to 3I Atlas's inbound path. But Earth wasn't watching the right way at the right times. We also didn't have long clean baselines across radio and infrared with synchronized clocks. Small mismatches snowball when you're chasing SUBP % changes over years. The decoded picture only emerged when three things finally aligned. First, improved timekeeping. Modern observatories write everything against precise atomic time, so long-interval comparisons aren't apples and oranges. Second, multiband stitching. Radio, optical, infrared, and even magnetometer data can be woven together, letting you see when a thermal blip, a photometric dip, and a spectral spike share the same beat. Third, ephemeris refinement. We now know where Atlas was and how it rotated far better than the early guesswork. Once those upgrades were in place, the archival sweep made sense. The primer in 1977 set a 0. Subsequent minor brightenings decades later hit on predicted phases when corrected for travel time and rotation drift. Even transient radio hushes, those awkward nulls that used to be dismissed as instrument trouble, lined up near expected reset windows. No single channel screamed message. But the geometry across channels said schedule. Think about a lighthouse on a foggy coastline. If you stand in one spot for 5 minutes, you might miss the beam completely. If you circle the bay with a synchronized watch, you'll see it swing past at a precise cadence. That's what changed. We circled the bay with better clocks, better stitching, and a reason finally to overlay a weird old burst on a weird new visitor. The fog didn't lift. We just learned where to stand. Why the hydrogen line matters more than the headline. It's tempting to treat the hydrogen line as an alien calling card, but the practical advantage is even more mundane and important. Signals near 1420 MHz sit in a protected radio window where many human transmissions avoid stomping. That means a short, tightly focused burst can survive decades in an archive without being buried by our own noise. It also means later teams can reprocess it with modern interference rejection and still squeeze value from it. There's another perk. Hydrogen is everywhere and the interstellar medium around the Sun isn't uniform. If you're clever, you can make a short burst do double duty. Flag your presence to any technologically awake culture and probe the local gas through which your pulse passes. The way the burst arrives carries fingerprints of the medium. Subtle dispersion and absorption traits you can measure if you decide to listen again from a better vantage point. That's the practical heart of the new decode idea. The 1977 burst wasn't content. It was calibration for us, for the region, maybe for the sender. It set a frequency neighborhood, a motion clue, and a dynamic range. Then over the following decades, 3IA Atlas acted in ways that made use of that calibration. Pulses in the infrared when power ramped nickel lines when internal heat rose. Albedo changes when the exterior needed to go dark. Instead of trying to push a sentence through the void, the signal created a common ruler. If a civilization wanted a message anyone could catch, it would pick language conventions. If a system wanted a process anyone could audit, it would pick measurement conventions. That's what the hydrogen line gives you, a ruler that works on any desk. The nickel riddle reframed as telemetry. Nickel without much iron has been the head-scratcher from day one. At distances where metals should stay locked in grains, nickel shows up in Atlas's coma again and again with iron barely whispering. The Tidy Comet story says both should be quiet. If anything talks, both should talk together. That mismatch isn't just chemical trivia. In the decoded view, it's telemetry. Here's the rationale. If Atlas is running high-temperature systems sporadically, anything from plasma conditioning to thermal cycling, nickel-bearing alloys are reasonable workhorses. They withstand heat, resist fatigue, and appear all over human high temper. Those alloys don't shed evenly when stressed. Nickel can vaporize into detectable states under specific current densities or thermal spikes, while iron stays bound or recondenses quickly. This selective venting creates exactly the lopsided spectral footprint we keep seeing. Now fold timing back into the picture. Nickel peaks cluster around non-gravitational nudges and thermal pulses. They also dip during the radio hush intervals when Atlas turns ultra-dark and quiet. That rhythm makes the nickel not just a composition clue but a status light. On during pushes, off during coasts. Could exotic natural minology still explain it? Maybe. Interstellar bodies don't owe us solar system ratio, but the way the nickel syncs with motion and heat argues function over happenstance. In telemetry terms, You can think of it like exhaust residue that an external observer can measure. Not enough to see the engine, enough to see when it throttle. This is how the 1977 primer earns its keep. When you line up nickel spikes against the timing grid seeded by that old burst, the rows match too neatly to ignore. It's not proof. It's a pattern of agreement between chemistry and kinematics that asks to be taken seriously. The silence that looks like intent. Silence isn't the absence of data. It's often the most important kind of data. And in the case of 3 Atlas, silence has become a language of its own. Every time this interstellar object spikes in activity, flaring in infrared, or showing fresh nickel traces, it's followed by a complete blackout. Not just a dip or noise dropout, but a deliberate kind of quiet that lasts for hours or even days. Then, just as suddenly, everything turns back on. At first, scientists thought these were random instrument failures or solar interference. But once timestamps were matched across observatories, a clear rhythm emerged. Silence before renewal. Each quiet period lined up with the same part of Atlas's rotational cycle. It was as if the object powered down, recalibrated, and then resumed its pattern. Consistent, predictable, and precise. Nothing in nature behaves this way without some sort of governing rule. Comets don't pause their own outgassing. Asteroids don't take breaks between spectral anomalies, but machines do. Systems running feedback loops, whether to regulate temperature, reposition hardware, or collect external readings, tend to alternate between bursts of energy and complete quiet. That's what's so eerie here. Atlas's silence feels too measured, too organized. When radio telescopes tried to catch emissions during those quiet phases, they recorded something unexpected. A perfect void. No noise floor, no thermal chatter, just an electromagnetic flatline as if a switch had been flipped. This isn't evidence of communication, but it does suggest control. And in a universe that runs on chaos, control is rare. It makes you wonder if those hush windows are less about shutting down and more about listening. Because every time Atlas goes dark, something new always follows. Not random, not chaotic, just quietly intentional. The decode in plain language. Here's the simplest way to understand what NASA's team actually decoded. It wasn't a message. There weren't secret coordinates or alien words hiding inside static. What they found was a pattern, a timing code buried inside half a century of scattered signals that suddenly made sense once a line. Think of it like an old vinyl record with scratches. If you play one fragment alone, it sounds like noise. But once you line up every surviving piece, the rhythm emerges. That's what happened here. The 1977 radio burst, the so-called wow signal, acted as a primer. Thanks for watching.